Hello everyone, I'm Stefan. In this tutorial we're going to calculate the distance, this one here, and the height and the time that takes from here to here, and the time, it will be the half of the time anyway, just multiplying 2. We're going to calculate the same thing we did in the previous video, but in this video we're doing it in a different way. It's really very easy comparing to another one. Where we find last time that the height is 5.408 and the distance, this one here, is 12.48, and the time to go, the ball comes from here to here, is 2.08, and the time of here is just half of it to arrive to the highest point here is just 1.04. And we calculate the initial velocity in x-axis is 6 meters per second, and in the y-axis is 10.40 meter per second. So we find it last time. We are going to see if we can find same results with a different way. It is really very easy. First of all, let's forget about the x-axis. Let's visualize this ball in the y-axis. We know that the time that takes it from here to here is same time that takes it to here. It's same time and same energy in y-axis. Therefore, this will be the height is same as here. So we're going to calculate the height in a different way. We're going to use mechanics of conservation of energy. We know kinetic energy 1 plus potential energy 1 is equal, for example, to kinetic energy 2 plus kinetic potential energy 2. We can say initial and final, for example, same thing, whatever you want to call it. So we know that energy is here is same as energy is here, and we're going to assume, doesn't matter what the mass you can put here, we assume this ball has the mass is 1 kilogram. M is 1 kilogram, because it doesn't matter the mass, because it doesn't when it's going to in y-axis it doesn't depend on the mass. Whatever mass you put here, whatever mass, and you send it in this velocity, velocity is going to arrive to this point no matter how much how many kilograms has. That doesn't depend in the mass. The only difference is if it's very heavy, you need a lot of energy to send it to make it goes in this velocity here, but if it's very small you need less energy. But since you are sending it in this velocity, it will arrive to this point, doesn't matter how heavy or light it is. So therefore let's assume that this ball has 1 kilograms. Why 1 kilograms? Because it's very easy to calculate. It's just number 1, and let's see what we're going to get. And I start putting our formulas. We know that this is here, since here we have 0, the height is 0, the potential energy is just 0, the first one. So let's write it. So we will end just with kinetic energy. Let's write it down. We have kinetic energy initial is just equal, and here in this case here we have this here, in this time, in this here, the ball, it doesn't move anymore. It's just in the y-axis is not moving. The v is 0 here. Vy in this point is equal to 0 final. Therefore the kinetic energy is just 0, so we will end just with the potential energy final. Therefore what we're going to get, the kinetic energy is just 1 over 2 m v squared, and we have this vy 0 squared because we're talking about here, and we had vy squared is this one here. We calculate here is 10.40 and is equal, and the potential energy in that point is just the weight times the height. And what is the weight? It's just m times the gravity constant is g times h. So we have here 1 over 2 m, we say just 1, and anyway we can cancel m here or just put 1 times v0 squared, vy0 squared is just 10 times 40 squared is just equal, and the gravity is 10 times the height. Therefore the height is just 10.40 squared over 20. It's just here is just 10 times 2. You can take this down here, divide it and divide it here. It will be h equal this one. And let's see how much is going to get here. This is very easy and short than the last example. So what we're going to get is 10 times 40 squared divided by 20, and we get 5.408 meters. As we see is a same height as we get before, is same height as there, as this one here are same. So we get the height, we know that is the height. So let's find the time here, the time. So let's make another assumption. What are we going to assume in this case? We're going to assume as the ball is arrived here and stopped here, and we make it fall, and we make it fall straight here. So where is going to fall? Is going to fall in the middle of this line. If we see this here, is going to fall. Actually, is going to fall in the half time. It will be half time and half distance. This will be d over 2 and time over 2. This point here. So let's assume that when the ball here and this here, it doesn't go like this, just fall here. So when it fall here, what is the equation? We have the equation, let's go back to kinematics. We have y, in this case this y here, the h, let's just call it h. We have the h, it will be, it just will be v0 is just 0. We have here v0, vy0 just 0, because we're just leaving it go down. So we will be, we know h is h0, we give it 0, h0 plus vy0 t plus 1 over 2 gt squared. G is just is the gravity. So what we're going to get in this case, we have this is equal to 0, and we have this is equal to 0 because just v is not moving, just we leave it go. So we will end with this one. This one is just 10 divided by 2 is just 5. This is square here, is just 5 t squared. So we now have h is equal 5t squares. Therefore the time, we're looking for the time is equal h over 5, and we put this is squared. Therefore t is just square root of h, and h, how much we find is 5.48, is 5.408 divided by 5, and let's see how much is going to give us. We have square root of, of 5.40 divided by 5, and we get 1.04. So the time here, the time is this point here is just 1.04 second. Therefore we multiply into, this is the time, this one here, t, we can call it t over 2. Just call it t over 2 here because we're looking for that one. Squared, t over 2 squared. So the time, just multiply into, we make it big T, is just equal 1.04 second times 2 is just 2.08, and this the time we have, and here is we get same results even we are assuming stuff is here. Acceleration in x-axis in this way here is just 0, is no acceleration, and we have the velocity is constant here, so therefore x is in the y-axis the distance, it will be x is just equal to d, and is equal to x0 is just 0, this is just write x0 plus vx0t plus 1 over 2 a t squared. We said this is equal to 0 because acceleration is 0, and we have is equal to 0 because we take this is the origin, so we'll end with v0t, and is going to give us is just 1 over 2 sorry, is going to be just v0 x is just 6 times the time, and is going to be 6 multiplied in 2.08, and is going to give us, let's see, 12.48 meters, and we see here is same answer we get in the previous classes, just different way. You see is here is same answer is here, by the way this is height is meter, this is meters as well, and this is second. I forgot to write them down, and hopefully you enjoyed this video, and you see is very useful, is better than other way because it's very simple. Look, we don't write that much, and thank you for watching. Hopefully you share and subscribe and like and wait for next videos. Thank you.